up and try again.
Welcome back. So, in the past, we've been working with the implementation of my linked list. As you can probably see in this piece of code that we have here in the past, we declare a constructor, a accessor, just to checking if the current linked list is empty or not. Then we implement the add method. The add method is quite important since we check two possible cases. One, in case it's empty, it's no problem. The first and the last element of this linked list is the same as the node that we create. However, if it's not empty, then we have to basically make this connection, the connectivity between the last.next that will point to the new element that we want to create. After we create or after we establish that connection, then we reroute our current last. This is a little bit elaborate. We discussed this in previous lectures. And then we create a couple other methods such as like the size and the find. Today we're going to talk about in particular countDuplicates. CountDuplicates basically will do search in the linked list, and then once you provide a target, it will count how many times that target appears in the actual list. So I want to elaborate a little bit more in this video about the importance to have this public interface. The public interfaces, we already talked about that in recursion, kind of helps us to interact with the computer user. So the computer user only is interesting to provide you a target and find how many times that target appears in the actual list. It doesn't really care what's the first, what's the last. So this is the actual interface, if you want to call it that way. So if you remember the tester, in the tester we kind of create or add a couple of elements. For example, C as start computer, B, D, and start compress. So we're interested to know how many duplicates of C there is there. So here we add one C. Let's add a couple more, maybe towards the end. I'm just gonna steal that piece of code. I'm gonna put here C, and then maybe just before the end we add another C. So we have 1, 2, 3 C's. Only for the purpose of this, I'm gonna remove most of this code. I'm just gonna add them, and then I'm gonna, sure, why not? Let me just remove the adding messages, and the only thing we're gonna test is right now we're gonna test the duplication, and then we're gonna talk about lowest in a little bit. Okay, so you notice that in the interface, when we actually declare this in the tester, this is where the computer user interacts with the whole code. The only thing that we're gonna do here is count the number of duplications in C. Yeah, so this is what we're gonna define today. We're gonna go back to my linked list, and this is what I'm trying to say. So regardless of what the public is, the public interface is we interact with the user privately. We're interested to send the same target to another method, usually the same name, but also with the reference when to start. We usually know we need to start from the first, and we're gonna move all the way until we find it, or we found the null, just in case we went through the entire list. That's what it means. So it will create a private method, again with the same return type, same name, same string target that we were interested to find. And of course we need the reference to what we call the dummy. In this case will be the first. Okay, so in previous videos we discussed why we need to consider the dummy for the first, because we don't want to empty the entire list. So since we're claiming here in line 34 that we're gonna give back an integer, we need to put here the counter, return the counter immediately. So this, just to make sure that the code works. If I attempt to just save it, yeah, I save this thing, and then my linked list.java, this will compile successfully. because syntaxically speaking, in this we're claiming we're going to give back an integer, and we are giving it back an integer. So that's the way we write some successful code. Now the next question is, when we're going to start, when we're going to stop. Since we already have the node that we pass as a parameter, we can create a statement that says, well, as long as we don't hit the null, yeah, we're going to trigger this search. Basically, this while loop here means search. So we're interested to search. When we get out of the search, we're going to report the counter. The counter is just going to keep track of how many elements there were duplicated as a target T. So in the middle, yeah, if we already know, I don't know if you can recognize, we're creating patterns of searching. Here's the dummy, here is the while loop. We have the dummy, here's the while loop. So the only thing we're gonna do inside of the while loop is to check. Yeah, we're gonna check for something. Now, after we're searching, we need to move forward. So the only thing that I'm doing here is they're gonna keep track of the components of a loop. And we know that we're gonna need to move through the dot next. In previous code we have done there, yeah, it's very similar as line 25. We're trying to do define. So this is how we move forward. Now, the condition is this is a little bit different here in the count duplicates, because we're only interested to find if the string appears in the linked list. So how are we gonna know this? Well, if t that equals, notice it's equals, because we need to recognize that the fact that we are comparing strings. As a matter of fact, why don't we do this? In the node, in the current node that we have, there is a value. And if you notice, then the value that we have there is a string. So this is that value is a string that equals to the target that we're looking for. Remember that we can do equals like that. And if that is true, the only thing we have to do here is the counter plus plus. That means that there is a duplication here, or how many duplicates there's here. This is basically defined. Now this works. This works, and if we come here and we're trying to, I'm gonna java my linked list tester, and I run my linked list tester. I have 1, 2, 3 C's, and that's where we have the 3 duplications of the letter C. All right, so that's count duplicates. Before we move to the next one, let's brainstorm in the recursive implementation. Yeah, I'm kind of hesitating a little bit, because notice that in the past we have worked with count duplicates. Publicly is only the loop, but here what we're doing here is we're creating this internal call. This is the key point here. So I'm exercising this feature that we have using Java. Java uses this polymorphic way to create multiple methods with the same name. Yeah, it's called method overloading. So method overloading means that you can have the same name of the methods if you want to, but this one has different parameters. So you can have as many as you want, many count duplicates as you want to. The only difference is that you can have different parameters. If you decide to have the same parameters, number of parameters, Java will complain. Check this out. So suppose I want to create another private method. Yeah, but this is going to be recursive. So even if we claim that this is going to be recursive, even if I attempt to save it, this software probably will tell you right away. Well, it didn't tell me, so I'm going to try to compile this part, and it will tell you that there is a method is already been defined in this class. Yeah, so be careful with this. Even it looks interesting here to see that you can have multiple count duplicates, but the truth is that you need to make sure you have different parameters. You can call here countDuplicates are. It's just if you want to distinguish this by the recursive implementation, just make sure you call on line 30 when you call internally countDuplicates are, because countDuplicates are takes the same target and it will take a reference to the next node. So once we have this part, recursively speaking, we don't need to have local variables. So we're gonna get rid of that local variables. So you might think that you might need to incorporate an additional parameter, but we're gonna use the stack, or we're gonna use the power recursion by using the stack. So here what we're gonna do, we're gonna establish our base case. Our base case is in case what? Well, if it happens that the dummy variable that we provide hits the null, that means that either the entire linked list is empty, or you just went through the entire list node by node, the next by next, and you arrive to the end. So at this time, there's nothing to return to the duplication part. Now, it might happen that you find it. If it's the case that you find it, then you need to check exactly what we did here. As a matter of fact, we can easily just copy and paste this part because it's the same case. So in case you find the drone that we're looking for, we need to add one. Notice that here we have a local variable. Here we don't care about local variables. So instead we can take advantage of this stack and we can just simply return 1 plus, and then here's when the trick comes recursively. We're gonna call ourselves with the same target. The only difference is we're gonna move that next. Okay. Now, base case number 1 is in case we arrive to the end. There's nothing to add, 0. Base case number 2 is a combination between base case and recursive case, which is in case you found it, you're gonna call yourself, but we're gonna add one. As a matter of fact, I think this is just a recursive case. Sorry about that. So we're gonna call ourselves, but this time with adding one. Now, if you haven't arrived to the end, or if you haven't found it, you need to move on. So this is the natural recursive case, and that's the case. Sorry about that. We're gonna return what? Basically this part. We're gonna call ourselves with the same target and move in next one by one. The only difference is that here we're gonna add one. So the public method again on line 30 will invoke countDuplicates are, which is a private method. Yeah, so this is your intellectual property. You don't really need to show to the user how you actually implement it. This is private. And in many occasions, this is what really counts as your intellectual property. Yeah, the rest is just interfacing with the computer user. I'm gonna compile this program again. Notice that I didn't touch my linked list tester. I'm just gonna run my linked list tester, but I didn't touch it because my linked list tester is the same. This countDuplicates will be invoked publicly to here, to line 30, but privately, you can choose which kind of method you wanna use. Here we claim we're gonna test the R one, which is the recursive one. And there you go. It's the same answer without any problem.